Hello, students. I'm Mansi Agarwal, Assistant Professor, ABES Engineering College, Ghaziabad. Today, we will be discussing our next topic of data structures, that is index sequential search algorithm. An index sequential search, also known as the index search, is a searching technique used on sorted data to reduce the number of comparisons needed to find any element. It involves creating an index structure to divide the array into blocks, allowing for faster access to specific parts of the array during the search. And in order to have a better understanding of how the index structure is created and how the array is divided into blocks in order to reduce the complexity as compared to the sequential search, let us take an example. Suppose we want to search for any value in the array which is given here. Suppose the target value that we want to search is 34. Suppose the target value that we want to search is 34. So in order to do so with the indexed sequential search, we have to divide this input array. We have to divide this input array into blocks. Suppose the block size that we are taking is equals to 4. Suppose the block size that we are taking is equals to 4. So in this case, what we are going to do is we are going to divide this input array into the blocks of 4 elements like this, into the blocks of 4 elements. And then using the indexed array, which we are going to build, and we are going to see how to build the index array. We are going to first find out the probable block in which the value can be found. And then we are going to sequentially search for each element in the block in order to find out the target value. So how indexing is done, how the indexed array is created. Suppose we are taking another array with the name array indices, right? We can take any name. Here I'm taking array indices. So this array indices will store the starting index of each block. This will store the starting index of each block. So here we can say that the first index is 0. And if the block size is 4, then the next index becomes 4, the next becomes 8, and the next index becomes 12. With this array, which is storing the indices, we have to also create another array that will store the elements, which are present at these indices. That means we can say that we have to only store the elements that are placed at the first index of each block. So here you can see that at index 0, the value is 4. At index 4, the value is 27. So we can store this 27 in the next block, and the value stored at index 8 is 80. So here we are going to store 80, and the value stored at index 12 is 90. Now, how this index sequential search is going to work? So first of all, basically what we have to do is we have to search this 34. We have to compare this target value 34 only with the values which are stored at the indexes stored in the indices array, right? So here, first of all, what we are going to do is we are going to compare this 34 with the value which is stored at index 0. Now, as you can see that if the value that we are searching is less than the value which is stored at the index 0, then it is definitely going to be an unsuccessful search, right? Now we are going to jump on the next index. We are going to check whether the value that we have to search is less than the value which is stored at index 4. But this is also not the case. Again, we will jump on to the next index. We will look at the index number 8. The value which is stored at index number 8 is 80. And here we can say that the value which we want to search is less than the value which is stored at 80. Now, as the input array that we have got is sorted, value was not less than the index, the value which is stored at index 4, but it is less than the value which is stored at index 8. So here I can say that the value, if it is present in the array, then it must be present from index number from index number 4th to index number 7th, right? From index number 4th to index number 7th, because we are saying that it was not less than 4, but it is less than 8. So it can be present anywhere in between 4, 5, 6, and 7. That is our second block. So with this process, we have got the block. Now we are going to sequentially check at each index which we have got, the index of the block that we have got. So we are going to check at the index number 4, at index number 5, and at index number 6. And yes, here we are going to get the correct value and our search will be successful. Now, in order to make a pseudocode for this algorithm, we can say that the first task is to create the array of indices and the array of elements, right? So for this, what we are going to do is we are going to start a loop. We can say that for I is equals to 0, for I is equals to 0 to n, for I is equals to 0 to n, what we are going to do? We are going to make the array indices. We are going to make the array indices. And we can say that if the index of this array is represented by IND, then we can say that array indices IND is equals to I, right? And the corresponding element that is to be stored in the array of elements at the same index. So array elements at the same index will store the value, and the value is stored in the original array. Suppose the original array is given a name of ARR. Suppose the original array is given the name of ARR. We can say that ARR elements IND is equals to ARR I. We can say that ARR elements IND is equals to ARR I. Here, the value of IND, the variable IND will start from 0. So we can say that this IND will begin with 0. And after every iteration, this IND will be incremented by 1. The value of IND will be incremented by 1. But the value of I will be incremented by block size. It will be incremented by block size. Suppose the block size is stored in any variable B, then we can say that I plus equals to B. We can say that I plus equals to B. So this is how we can create these two arrays to store the indexes and the corresponding elements, right? The next task is to check whether the value that we are searching, if it is less than the first element of the array, then it is going to be an unsuccessful search. So for that, we have to check whether the target value is less than, we can say, if it is less than ARR of 0, if it is less than ARR of 0, then we can simply say that the search is unsuccessful. The search is unsuccessful. Right. But if this is not the case, if the target value is not less than the first index, then what we are going to do? we are going to check the target value with only with the values which are stored at the boundaries of the blocks, right? At the boundaries of the blocks. So for this, we are going to start checking the target value, that is 34 in this case. We are going to start checking this 34 with the value which is stored at the second index of the indices array, because we have already compared it with the first index and we have seen that if it is less than the first index, then it is unsuccessful search. So now we are going to check from the second index, right? So we can say that for, we can take any variable I, which is equals to 1, which is equals to 1 to the number of elements in the number of elements in this index array. So we can say that for I is equals to 1 to the number of elements in the index array, we have to check if if the target value, if the target value is less than, if the target value is less than ARR of elements, ARR of elements, because we have to compare it with the value which is stored at that index. So we can say that if the target is less than ARR elements I, then in this case, we have come on to a decision that the value might be present at the block whose, which is present just before this index, which is present just before this index. So in this case, let us take two more variables. We can take beginning and end, such that this beginning will store the starting index of the block size of the block, which is probably which is going to have the target value, right? So we can say that the beginning is equals to ARR ARR indices, that means the index, and which index this going to be? The index of the previous block, right? So ARR indices I minus 1, right? And the end index is going to be ARR indices, ARR indices I, ARR indices I minus 1, ARR indices I minus 1. Let us try to understand these two lines a little bit more. Suppose if we are searching for 34, right? In order to search for 34, first of all, we will compare this 34 with the value which is stored at index 0, that is 4. If it is less than 4, then we are going to simply say that the search is unsuccessful, but this is not the case. So we will move on to the else part. In this case, we will start with the value I is equals to 1 to the last index, right? If the value of I is equals to 1, we have to check whether the target value is less than the value which is stored at index 4 or not. Now, the value which is stored at index 4 is 27, right? And the target which we are searching is 34. Again, the condition is false. So we are going to increment the value of I and we are going to move on to the next index. This is the starting index of the third block. This is the starting index of the third block, right? Now, if the value that we are searching, that is 34, if it is less than 80, that means the value that we are searching is less than 80. It is not present in the third block, rather it is present in the previous block, right? So the value that we are searching will be present at the index 4th, 5th, 6th, or 7th. So for this, what we have taken is, we have taken two variables, beginning, that will store the array index, which is the starting index of the previous block. And we have taken another variable end, that will store the last index of the previous block. And what is going to be the last index of the previous block? The array indices I, that is 8 in this case, minus 1, that is 7. So here we have got the value of beginning as 4 and the value of end as 7. Now, the next task is to sequentially search. We have to sequentially search from 4 to 7. So for this, we can take another loop. We can say for I, starting with beginning, to end, right? For I starting with beginning to end, we have to check if the target value, is equal to the value which is stored at index I or not, right? Now, if the target value is equals to the value which is stored at index I, that is starting with beginning till end, then we can say that we have found the value. And for this, we can say that we can change the value of any variable flag. We can take a variable flag and we can say that the value of flag can be modified to, we can say that the value of flag can be modified to 0. And initially we can take the value of flag here as 0. Right. So here we can put flag as 0. Now, after coming out of this loop, we can simply check whether the search is successful or not with the help of checking the value of flag. If the value of flag comes out to be 1, then the search is successful. Otherwise, the search is unsuccessful. Now, in order to compute the block size of the index sequential search, suppose n is representing the number of elements. Suppose n is representing the number of elements in the array, and the block size is represented by a variable b. Suppose the block size is represented by a variable b. So we can see that the total number of blocks that are being made with this input is n upon b. This is the total number of blocks. The total number of blocks that can be made is given by n upon b. So as we have already seen that the comparisons which are required with this input, we need to first compare with every starting index of the block, right? So this makes it n upon b comparisons. And then when we find the most probable block, then we have to check for every element in that block. So which makes it n upon b plus b. So these are the number of comparisons that we are going to make. Now, in order to minimize the total block size, we can say that we can differentiate this value with respect to the block size. And with this, if we say that we need to differentiate the total number of comparisons, we can have an equation wherein we are differentiating it with the respect to b, right? So this becomes d upon db n b raised to the power minus 1 plus b is equals to 0. Here we can see that after differentiating this value with respect to b, the value that we got is minus of n. We got minus of n upon b square plus 1. We got minus of n upon b square plus 1 is equals to 0, right? And from here we can say that the block size b, can be represented as root of n. Can be represented as root of n. And this is how we have taken the block size of 4, as the number of elements that we took was 14. So for that, the block size should be taken as 4, right? So as you know that the value of root 14 comes out to be 3.74. It comes out to be 3.74. So here the block size can be taken as 4. So let us see the implementation of this searching technique with the help of C language. Here we have made a function, a user-defined function with the name index sequential. Here the parameters that we are taken are array and the size of the array and the value that we need to search. And as I have already discussed while discussing the algorithm, that we need to have two arrays with the name array indices, and in order to store the element, we can take array element. The block size here is taken as 4, and we have taken a few more variables, including I for running the loop and the ind for storing the index of the arrays that we have to make. And then we have taken beginning and end in order to store the first and the last index of the block in which we have to perform the sequential search. And then we have taken a flag that will tell us whether the search was successful or not. In this case, we have first created the array indices and the elements. For this, we have traversed the initial array from 0 to the last index, and we have incremented the value of I with the block size, that is 4. And in every iteration, we have stored the index in the indices array and the corresponding value in the element array. And we have also incremented the value of ind. Now, afterwards, we have also stored the value of n-1 as the last element which is stored in the array as one of the values in array indices and array elements. This is done in order to store or to make the last block of the input array. As you have seen in the example, if we had 14 elements or if we had 13 elements and the last block was at 14, was at 12. So in order to store the last index, we have explicitly stored it in the array, thereby storing the value of n-1 and its value which is stored in the array, right? Now, the first case where the value, if the value that we are searching is less than ARR I, then we can simply say that the search is unsuccessful and we can exit the program, exit the function, and we can say that the search was unsuccessful, right? But if it is not the case, then we have to iterate from the second index in the indices array till the last index. So here we have taken I is equals to 1 to equal to the indices, and that is ind. And then we have to check whether the value is less than array element which is stored at the index I or not. If it is so, then the beginning will store the index of the previous block, the starting index of the previous block, and the end variable will store the last index that is given by ARR indices I minus 1. And here we will break and come out of the loop, as we have now found the block in which the value can be present. There is no further need of going on to the rest of the elements. Then we are going to sequentially search the values. In order to search sequentially, we will start the loop from beginning till end. And if the value is found, then we will change the flag to 1 and we will come out of this loop. Afterwards, we will check whether the flag is equals to 1 or not. If it is equals to 1, then we will say that the value is found at index I. And if it is not so, then we will say that the search is unsuccessful. But in this case, there is one edge case that the value may be present at the last index, as we are comparing we are saying that if the value is less than array element, here we are saying that if the value is less than array element, so there may be a case that the value that we are searching is present at the last index. So that will not be included in this loop. And in order to do so, we can simply check whether the value is present at the last index or not. If it is so, then we can simply say that the value is found at n-1 position. The references taken in order to make this video includes the data structures using C and C++, fundamentals of data structures SHORM series, and the Rejas data structures using C. Thank you.